So the equation looks like this. Y is equal to A sine bracket bx plus c, square, close bracket, plus d, which is the form that the calculator, when we do the regression equation, that's the form that the equation is going to come out of. Okay? The equation of the well, let's start with the median value. So the median value is d, which is the maximum plus the minimum divided by 2. It's the average, right? It's in the middle. It's actually the middle. Median is the middle. But in this case, because it's only two numbers, it's just the arithmetic average, or it's also the mean. Right? Just add them together, divide by 2. The equation of the midline, so if we ask you for the equation, you're going to write y equals, and then that value. So if you calculate d, if you're asked for the equation of the midline, you're just going to write y equals d. The amplitude. So the amplitude is the distance from the midline to the maximum or from the midline to the minimum. And it's maximum minus minimum divided by 2. Because max minus min is how far apart they are, right? Even if one is positive and one is negative, because if the one is negative, let's say you're going 10 minus negative 2. So we know those should be 12 apart, right? Because you got 10 and then you got 2 below. But 10 minus negative 2 becomes 10 plus 2. That will give you the distance between the max and the min, and the amplitude is half of that distance, so we divide by 2. The period is the length of the interval of the domain to complete one cycle, right, or the length of one cycle. If in the equation y equals sine bx, they give you a b, the period is 2 pi over b. Okay, and that's actually on your formula sheet. Speaking of formula sheets. So on the formula sheet, you've got the two things for sinusoidal. You got the y equals a sine b bracket x plus c plus b, and then you've got period of 2 pi over b. Now, the start point, which we will talk about as we go through. You can get the start point, so if you've got the equation, a sine bx plus c plus b, you can get the start point by going negative c divided by b, the negative of c divided by b, comma d. So the definition for the start point of a sinusoidal function is where the curve intersects the midline and first starts going up. So this one would start at 0, 0. Something like this. Okay, so if we had the midline, which let's say was here, this would be starting either here or here. So what you do is you go to the y-axis, you go to the closest, you find the midline, you go to the closest point on the curve where it intersects the midline, it's going up. That's our start point. So we just give you the formula for it. It's a little bit different in 30-1. There's a meaning for b. It's a horizontal stretch. We don't do stretches and we don't do translations. We don't know transformations. So the only one we actually do is in sinusoidal. And so we just give you this formula to get you to that point. And let's take a look. So let's say we have a Ferris wheel. Graph below represents the height of a person on a Ferris wheel over time. Person gets on the Ferris wheel at x equals 0. So a lot of times maybe we'll call this the t-axis for time and the h. We're not. We're just going with x and y. So the x-axis is time in minutes, and the y-axis is the height in meters. And this 82 meters, that's actually the height of the first Ferris wheel ever. And the first Ferris wheel was designed by a guy named George Whitworth. Last name was Ferris. And he built bridges. So if you think of the older bridges in Calgary, like near the zoo, the ones that are iron bridge, where you see it's made out of iron and not like steel and concrete or whatever. He had the idea. He used to build those bridges, and he thought, hey, what if I took one of those, made it into a big circle, right? And then we could stick an axle in the middle of it, right, like a bicycle wheel, and we could create a rod. And he did that. It was in 1893 at the Chicago Exposition, and it was actually 80 meters high. Right? If you look out on the football field there, that football field between the goal lines is like about 100 meters. So it's a good chunk of a football field high, 80 meters high. It had 60 cars on it, so cars, not cars to drive, but a car that you would ride in. And was it 6 by 7? look it up, but basically it had like, let's say 60 cars that each held about 60 people. Actually, it had like 40 cars that each held 60 people. So for this ride, it would actually hold 2,100 people. So it could handle the big crowds. Anyways, this is a description of a particular Ferris wheel that has that. And what we're going to do is we're going to analyze this and see if we can come up with a sinusoidal function to match this graph. So what's the height of the Ferris wheel when the person first gets on it? What's this height? 2 meters. Good. I'm glad you said meters. So anytime we're talking about heights, we're going to append to that meters, right? Because the height is in meters. What is the maximum height of the Ferris wheel? So how tall do you go? 82 meters. What is the radius of the wheel? So if we think about a wheel, which I can't draw a round one, that's the wheel. It goes from 82 down to 2, and the radius is going to be kind of in the middle. What's going to be in the middle between 82 and 2? So if we want the middle, it's really, for our case, it's going to be the midline, right? The median. It's going to be halfway in between. So we say that the median, D, is equal to max plus min over 2. We worked out the max, right? Or we read it off of the graph. We said the max is 82. The min is 2 divided by 2, which would be 84 over 2. So that's 42. So the middle is at 42. So, but we want the radius. So the radius is the distance from the middle to the outside. So how far is it from the middle to the outside going up or down? So from 42 to 82 or from 42 down to 2 is how big? 40. So that's actually the amplitude. So anytime you get something circular, Ferris wheel, a car wheel, bicycle wheel, whatever, compact disc or DVD or vinyl album, anything that's circular, the radius will be the amplitude, okay? So if you get something circular, there's a car, tire, whatever, and we're looking at the motion of the valve stem as it goes up and down or whatever, the radius of the wheel is the amplitude of the sinusoidal function. So amplitude is max minus min over 2, which is 82 minus 2. So it's like how far apart are they, which works out to 80, divided by 2, which is 40. Okay. So the radius of the Ferris wheel is its amplitude, is the amplitude, which is 40. What's the height of the person after 1 minute? So 1 minute, 42. meters is the amplitude. The radius, that's right. The radius is 40 meters. Radius is 40. How long does it take for one revolution? How long does it take to go around? 4 minutes, right? So we start at the bottom, get up to the middle, reach the maximum, come back to the middle, back to the minimum. So remember, we're taking a sinusoidal function, we're splitting it into 4 parts. Okay? So these 4 parts, in this case, are from the minimum, where you get on, at the bottom, to the middle, up to the top, back to the middle, back down to the bottom. Is anybody reading the London Eye? Yep. Yeah. Yeah. So that's what they call in ride parlance, like at Disney, it's a continuous loader, right? So it's moving very slowly. So the people get out of the cabin and they exit, and then you're on the other side, and very slowly come by, and you just walk on, right? So they don't have to stop the thing.
It doesn't, or it's just way too fast for Ferris wheel, especially with that height.
Yeah, so the London Eye is half an hour,
30 minutes, yeah.
right? Especially because you're paying a lot of money and you actually want to see the sights, not just whip around really quick. So 4 minutes for this. actually isn't that tall if it's a ride and not a sightseeing thing. Right? So it's just a ride you're getting on. So you think you're down at Stampede, you ever ridden big wheels down at Stampede? That goes around fairly quickly, right? It doesn't take 4 minutes. It's not 80 meters high, but it also doesn't take 4 minutes to go around. Right? And it's partly sightseeing, but it's also, an amusement ride. All right, so what do we say? 4 minutes. So make sure there's units, right? So if it's x-axis, we're talking minutes, time, minutes, and if it's y-axis, we're talking height in meters. What is the amplitude of this function? All right, so we did that. Spoiler. So the amplitude is 40, right? But it's just the number. Okay, so amplitude is just the number. There's no, we don't have to associate units with it. So the amplitude is 40. The equation of the midline. What's the equation of the midline? What are you going to write? Y equals. Don't worry. I'll ask you for the equation of something on a test. You'll forget to write y equals. You'll lose that half mark for the fourth time. You'll go, oh. You'll start looking at this. Once the equation of the midline. Hint, right? There's a Q. It's on Monday. So tomorrow will be review, so I'll hand out tests tomorrow. You can go through them. I haven't quite packaged them yet into a package, but if you want to come in after school today, you can see them as well. But tomorrow I'll give them back to you. So look for stuff like that. If you're losing half marks because you don't have a y equals, then stop losing half marks. What is the period of this sinusoidal function? We did that, right? Somewhere. It's like 1 revolution, that would be the period, right? So 4 minutes. If we put all of this together, then the equation of the sinusoidal function for this would be y is equal to 40 sine pi over 2x minus pi over 2 plus 42. Now, you're not responsible for generating this, but we can look at the graph and generate this equation. And so, how do the values of A, B, and D? So let's start with D. What's the 42? Nope, not amplitude. What is it? The midline. So what's at the middle of a Ferris wheel? What's at the middle of any wheel? The axle, the hub, right? So on your car, if you got a car, right? The wheel sits on the axle, right? Or the hub. You got hub, that's why they call them hubcaps, right? At the hub. So the D value here, so D is the median, which is the middle. But on a Ferris wheel, should be capitalized, right? Some guy's name. On a Ferris wheel, it's the height of the axle or hub. Okay. It's the thing that's in the middle, right? So if you're talking vinyl, you got a vinyl LP, it's going to be the hole. Right? It goes on to the little spindle turntable, turns around, and that. Well, 33 and a third, really, right?
I guess so.
It's also 78. Get really old stuff. Well, but it's got to turn at 33 and a third, or it won't sound right. So 33, and if it's 45, you got the little spider thing that goes in, so you have big hole. Because in the jukeboxes, they have a large hub and a storage. What's A? In terms of the Ferris wheel, right? So we know the value of A. A is 40, great. But what is it in terms of the Ferris wheel? Sorry? What is it? What's the physical quantity? Distance from the center to the outside is the radius. So A is the radius of the wheel. Now, notice the B value, we know the period is 4 minutes. The B value is not 4. Okay, but we do have a formula, right, which says that B is equal to 2 pi divided by the period. So B is going to be 2 pi divided by 4, which is pi over 2. And we can see the B value is pi over 2. So if we can figure out the period, right, and on this we did, the period is 4 minutes, then we can get the value for B. The value for D and for A we calculated, so we could have filled those in. We didn't need somebody to give us this thing. We could have filled them in. The one thing that we don't know yet is this value. Okay? But if you graph this and you set your calculator window to give you this same kind of window, right, from 0 to 8, 0 to 84 or 90, whatever it is, then what you'll see, you'll look just like this. So what we're doing now is we're looking at a graph, and now we're actually going to generate a graph. So given some information, and what we've got here is 2 points. So we take a look at this. It deals with tidal heights. So everybody familiar with the concept of tide? We have them not in Calgary, right? We're landlocked. We do not have tides. But if you visit anywhere that's on a coast or that, you have the tide, right? So the pull of the moon's gravity pulls water, blah, blah. So water goes in and out. The tide goes in and out. So in Inverdean Harbor, the maximum depth of water is 22 meters, occurring at 1 a.m. and 1 p.m. So here we are. There's 1 a.m. There's 1 p.m., which would be 13 hours. Okay, so if we go on the 24-hour clock, after 12, it's 13, 14, 15. So in 10 minutes, the clock above there is going to turn to 1300. So it'll go to 13 hours. The minimum depth of water is 6 meters, occurring at 7 a.m. and 7 p.m. Okay, so let's graph that. So we have 6 meters at 7 a.m. So here's 7 a.m. There's 6. We can put that point in. And what time is 7 p.m.? 1900. So we go to 19 and also put 6. The depth is 14 meters at 4 a.m. So there's 4 a.m. and there's 14. At 10 a.m., there's 10 a.m., 14. 4 p.m. is what time? 16. And 10 p.m. is what time? 2200. Now, why did they give us 14? What's special about 14? Like 22, I get it, right? That's the maximum. And 6, I get it. It's the minimum. Yeah. It's a midline, right? It's halfway. So if we said, look, you gave me a max and a min, right? So we know that D is equal to max plus min over 2, which is 22 plus 6 over 2, 28 over 2, or 14, right? And that'll be meters. So at 14 meters, there's our midline. I always like to sketch a midline in. Right? So they didn't really have to tell us that 14 meters, well, they didn't have to give us anything about 14 meters. As soon as we had the max and the min, we can actually generate those points, right? So we'll see, well, how is it we could have just put those points down by using what we know about a sinusoidal function. And it says, calculate the amplitude, period, and equation of the midline. Okay, boom. So we've got the equation of the midline because they gave us the max and the min. Now, what's the period? So the period is just how long does it take to go from the maximum back to the maximum. So from 1 a.m. to 1 p.m. is how long? 12 hours, right? So if we know that the period is 12 hours, and we know that a sinusoidal function is split into 4 parts. So if I'm starting at the maximum, so what's 12 divided by 4? 3. So if I start at the maximum, it'll take 3 hours to get to the middle. Then another 3 hours to get to the minimum. So we could have done this point simply by going 1, 2, 3 and going to the middle. So we could have figured out the midline was 14, right? We didn't need them to give us these points. Just they give us this and this and the period, and we're good. We could have done the whole thing all by ourselves, but I mean, they gave us more. But we could have figured out, look, from here to here is 3 hours. Then another 3 hours, 1, 2, 3, I'll be at the minimum. 1, 2, 3, back to the middle. 1, 2, 3, up to the max. 1, 2, 3, back to the middle. 1, 2, 3, down to the minimum. 1, 2, 3, back to the middle. And if we went 1, 2, 3, we would be back to the maximum. That would happen at 1 a.m. again, right? In this case, it would be 25 hours after we started, right? But 24 hours would be midnight. This would be back to 1 a.m. the next day. And if we go backwards, 1, 2, 3, then we could say, well, you know, at 11 p.m., you would have been at the middle, right? So 1 a.m., so 3 hours go back to 12, 11, 10, can't count. Count better on fingers, right? 1 a.m. minus 3 hours, 12, 11, 10. It would be 10, which I got the point right. And now we can sketch this with a smooth curve. So just make sure that you're not you don't have any V shape. It's not the greatest curve. It could be better, but it's not hard on the whiteboard. It's easier on paper, so I expect more from you. You got a piece of paper, and you got an eraser. You can always clean it up if need be. So there's our curve, right? Calculate the amplitude. Well, you know how to do that. Max minus min. We can also just count it, right? Start here, okay. 2, watch the scale, right? Scale is by 2s. 2, 4, 6, 8. Our amplitude is going to be 8. So let's calculate it out. So the max is 22 minus the min. 22 minus 6 is 16 divided by 2. A is 8. So 8, if we're talking about how does it differ, then we would say 8 meters, right? Period. So period, we said, was 12 hours. So period is 12 hours. So here's the nice thing. D is the midline, right? We know that D is 14. A is the amplitude, right? Take max minus min divided by 2, you've got A. B is not the period. So B is not 12 hours, right? Instead, B is equal to 2 pi over the period, which is going to be 2 pi over 12. And if we just simplify that, it'll be pi divided by 6. Okay? So you may get the B value as a number, right? When we do regressions, we're just going to get the B value as a value, probably rounded to 2 decimal places. Here, we've got it as an exact value. So let's state, so the equation can be represented by y is equal to A. Now we don't have C yet, so we're going to get C in a second. But we can write down A, 8, sine B, so pi over 6, x, plus C, so we'll just leave some space here. We'll figure out C in a second. And then midline plus 14. So we want to figure out the start point. So what we do is we go to the y-axis and the midline, and we say it's the first point where you start going up. So if we drew this, if we actually went from here and went 1, 2, 3 back to the midline, then we can say this is the start point. Or we can go over to here. So if we didn't draw this part, if we didn't have this drawn, we would go here and say, okay, there's the start point. So let's do this one, because we can all see it. It's at 10:14. Okay, so you go to the y-axis, you get to the midline. So y-axis, midline, you start moving along the midline until you reach the curve where it intersects the midline and it's going up. Okay, and that's when you have a sine function. And we say that's at 10:14. All right, so how do we calculate C? So we were told the start point is negative C over B, comma, D. All right, so the 14 is D. We know that. That means that 10 must be equal to negative C over B. Right, so the x value of the start point, which is 10 from the graph, right? We just get that point, 10. That 10 is equal to negative C over B. Now we know B. So let's do a little bit of work here. We'll just multiply both sides by B. 10B is equal to negative C. So C is equal to negative 10 times B. All right, now all we've done is we stuck in one number, the 10, that we got off the graph. And otherwise we've left it as B and C. And then we go and we say, hey, here's B. Okay, so C is equal to negative 10 times pi over 6. Okay, negative 10 times B, pi over 6. So you have 10 divided by 6, that's going to reduce. So C will be equal to negative 5 pi divided by 3. I'm going to just kick it up here. So our C value is minus 5 pi over 3. Yeah, there's two people amongst us who would say, well, if I factor the pi over 6 out of that, then I'll get my C, which is negative. It says go right, how much, and actually it's going to end up go right 10. Okay, but that's only two of you, and the rest of you don't have to worry about that, right? We just figured out the C value. All right, so let's see if that actually works, right? So what have we got? We're going from, let's say, negative 4 to 26 on the x. So I'm going to get out the graphing calculator. I'm going to make it, size it. I'm just going to clear it. 7, all reset. So here's the deal with your calculator for the newbie. It always stays in radians. Okay? The only thing we know about radians is that they exist. They're an alternate way to measure an angle. There's 2 pi of them in a circle. That's it. You don't have to do any conversions. Anything in this course, your calculator stays in radian mode. Okay, we're going to set a window to match this. So we're going to say, let's go from negative 4 to 26. And it goes by 2, 3, 4. It goes by ones. It's going to be a fair chunk of ticks along there, but that's okay. And where do we go from? So let's say negative 2 to 28 by 2s. So negative 2, so y min, negative 2 up to 28 goes by 2s. We're going to go to y equals. We're going to put this in. So anytime the calculator is cleared, it's going to go into radian mode. So your calculator should never be out of radian mode no matter what you do. So 8 sine. Okay, I'm going to go bracket pi divided by 6. Okay, so stick the pi divided by 6 in brackets. Right? That'll work on any calculator that we got going from the 83s up to the, the higher end 84s. And I'm going to go bracket 5 pi divided by 3. Oh, but I need an x after the pi over 6, so I'm going to go back here. So I forgot to put it in, so you go second function insert, and then you can put in the x. Okay, so if you ever forget to put something in on a line, you can just go to the spot you want it and do second function, hit the delete, it'll insert. Okay, after the 5 pi over 3, we're going to close that bracket and then go plus 14. So where do we get all these numbers from? We had 2 points on a graph. They gave us 2 points on a graph. Then they gave us some more points. Right? They actually plotted the 2 points for us. They gave us some info. We plotted some more points, and then some more points. We used that to figure out the d value. right? Max plus min over 2. That's where D came from. We got the amplitude, max minus min over 2. That's where the 8 came from. We figured out the period was 12 hours, so we used the formula, 2 pi divided by the period, 2 pi divided by 12, or pi over 6. That's where the B came from. And then we were given this. Start point is negative C over B, comma D. Forget about the G. We already know it's 14. That's good. We've already got that. It's the 10 we're interested in to help us calculate C. So we use that. That gave us a negative 5 pi over 3. If this is right, when I hit graph, we should basically see something that looks a lot like the graph that's in front of us. So let's find out. What's that? Yeah, you messed up. It's to be expected. One thing I like to do when I graph these, I like to throw in the midline. We'll look at it in a second. I like to throw in the midline to see, does it look like it's in the middle? Did I get the middle right? And do my points look like they're in about the right place? So we're thinking this should be 1014, right? Okay, that's what we've shown on the graph at that point. So let's find out if I do an intersect and go to that point. Yeah, we're close. And second grade, guess. And it's 1014. Right? X is 10, Y is 14. I know you just can't contain yourself. You're as excited as I am that, hey, they gave us a couple points and then a bunch more points. We plotted them all. But then we were able to use that graph and those points to figure out the value of D and then A. We got the period off of the graph, use that to calculate a value for B. We use then this formula for the start point to figure out what our C value was, and we matched that graph. Right? We have our calculator drawing the exact thing that we're looking at up here. So just check what I would check. If you're not seeing the same graph, just check that your pi over 6 is correct, that you've got bracket, pi divided by 6, bracket, then the x, minus bracket, pi divided by 3, bracket, then another one at the end. Right? So you got to close it off.
I have that, but it's not.
Is the minus with the side?
Hang on. Match each graph with one of the equations listed. So there are 8 equations, there are 2 graphs. So we've done this all the way through, right? No matter, except for rationals, right? With rationals, we don't do any graphs, but in logarithmic, in exponential, for linear, quadratics, cubics, exponential, logarithm, we match. So take a look at these guys, see if you can figure out which one's which. So part of it is, all right, what characteristic of the graph am I going to use? Can I figure out? So what's the easiest thing to figure out? Start there. Problem with y-intercept is it's not always A because it can move because of the phase shift. Yeah, I would start with the midline. So you figure out the midline of the graph on the left, then that narrows down. Okay, what are the possible graphs that it could be? They do midlines by counting, right? 1, 2, 3, 4, 5, 6. So 1, 2, 3. There's the midline. Now you've narrowed it down, right? And now you just have to figure out, okay, well, they both have the same amplitude, so that's not going to help me. But I do have a B value. No. So we know D is -2. Which 2 graphs are we looking at? Or could it be? Could be F or it could be H. So we look at the A value. They're the same. Okay, so that's not going to do anything, right? A is 3. We can verify that. Well, from here we go 1, 2, 3. Yep, A is 3. So what's the difference between the two of them? The b value. What do we use b to get? Period. So we say b is 2 pi divided by the period. Okay, what's the period of this graph? Here to here. What's the period? Pi. So, if I take 2 pi divided by 1/2, am I going to get pi? 2 divided by 1/2 is 2 times 2 over 1 is 4. So 2 pi, that'll be 4 pi. That's not the period, right? So let's try 2. What's 2 pi divided by 2? 5. So H is the answer. This guy here is H. So we started by finding the midline. We narrowed it down to 2 possible equations. Okay, that rotates. Got the amplitude. Nope, they're the same. So it's not going to distinguish between the two. What else do we have? We have different b values. What's b? Well, it's not period, right? But it's used to calculate the period. Okay, so try that on this guy. So same idea. Find d. See if that narrows it down. Oh, it does. So what's d? Okay. And you can just count. You can actually eyeball it. Right? Okay, so what's d? -1. Okay, what are we looking at then? G. We're done. Okay. You didn't need to go any further. Right? Like that's enough. Now, okay, let's check a little further. What's the amplitude? Well, from the middle, 1, 2. Okay, that matches. 2 divided by 1/2. 2 pi divided by 1/2. We just did that. It's 4 pi. So then this period should be 4 pi. So from the middle, go up, down, okay. It's not easy to read, but that says 4 pi. So that matches. So this is G. Any questions?